Alright everybody, in this video we're going to learn how to use the properties of a parallelogram. Now the definition of a parallelogram is that it's a quadrilateral, so a four-sided figure, whose opposite sides are parallel to each other. Now other than the fact that opposite sides of a quadrilateral have to be parallel for it to be a parallelogram, that property exists, but then there are also other ways that you can tell the quadrilateral is a parallelogram. So for example, opposite sides and opposite angles. So if a quadrilateral is a parallelogram, then we know for a fact that its opposite sides and its opposite angles are congruent. So then let's draw a parallelogram here and show how that works. So if we know if it's a parallelogram, we have the opposite sides being parallel to each other. So then this set plus this set are parallel, and then these two opposite sides as well. Okay, so then the opposite sides, A, B, C, D, are going to be congruent. So AB is congruent to DC, and then BC is congruent to AD. Okay, that set of sides are congruent, as well as the opposite angles. So angle D and angle B have two angle marks to indicate that they have the same measure. Okay, so we can say angle ADC and angle ABC, as well as the other opposite angles. Angle DAB is congruent to angle BCD. Alright, for example 1, we have to use the properties of a parallelogram to find the values of x and y. So if you look at the diagram, we have opposite sides that are parallel, so then we can automatically say that this quadrilateral ABCD is a parallelogram. So we know from the previous slide that the opposite sides and opposite angles of a parallelogram are congruent. So then AB is congruent to DC. So the measurement of AB is x plus 4, the measurement of DC is 12, so since they're the same measurement, we can set up an equation x plus 4 equals 12. So solve for the value of x, subtract 4 from both sides, and then we get x equals 8. Now using the other property, the opposite angles of a parallelogram are congruent, we notice that angle A is y degrees and angle C is 65 degrees. Well, these two opposite angles are congruent. So angle BAD is congruent to BCD. So here's BAD. BAD, talking about the one angle that's measured with y. And then angle BCD has a measurement of 65 degrees. So then y is the same measurement as 65 degrees. Now another property of a parallelogram is that it's consecutive interior angles of a parallelogram. Well, we're talking about those specific angles. So if the quadrilateral is a parallelogram, then we can say that its consecutive interior angles are supplementary. So we're going to remember supplementary means that the two angles will add up to 180 degrees. So we have a parallelogram here. Opposite sides are parallel, so we're going to label the vertices A, B, C, and D. Okay, so consecutive interior angles are angles that are following right next to each other. So for example, D and A are consecutive interior angles. A and B are consecutive interior angles. B and C are consecutive interior angles, as well as C and D. So this property says that if the quadrilateral is in fact a parallelogram, then we can say that the consecutive interior angles are supplementary. So then angle A and angle D together would add up to 180 degrees. So applying that property, if KLMN is a parallelogram, find the values of x, y, and z. So there's a lot going on in this diagram, but we do know for a fact that the quadrilateral KLMN is a parallelogram. So let's break down the different components that we have to find, and then we can finish this problem. So we have to find the values of x, y, and z. Let's first find the value of x. So here's our x. Kn is 2x minus 3. Lm is 37. So since we know that in a parallelogram opposite sides are congruent, we can say that 2x equals, Kn is congruent to Lm. So we can say 2x minus 3 is equal to 37. Solve for x. Add 3 to both sides. 2x equals 40. Whoa, too fast. Sorry guys. And then we divide both sides by 2 to get x equals 2. 20. Alright, so we found x, which is 20. Let's find the value of y. So the angles, opposite angles in a parallelogram are also congruent. So we can say the angle KLMN is congruent to KLNM. So KLMN is talking about angle L, and KNM is talking about angle N. So these two angles are congruent. So we can say that y is equal to 23 degrees. Okay. So the last property that we just learned was that the consecutive interior angles of a parallelogram are supplementary. So the angles right next to each other. So 123 and z would be supplementary, z and y would be supplementary, and then y and whatever this mysterious angle would be supplementary as well. So we know that z and 123 would be 180, as well as z and y. So angle LKN plus angle KNM is 180 degrees. We know that z plus 123 would give you 180. So to find the measurement of angle z, subtract 123 from both sides, z equals 57 degrees. Now the last property of a parallelogram we're going to talk about is its diagonals. So if a quadrilateral is in fact a parallelogram, then we know that its diagonals bisects each other. And what that means is that if we have a parallelogram, opposite sides are parallel, we're going to label it A, B, C, D, and we draw one diagonal. Okay, so a diagonal goes from vertex to vertex. Okay, now this diagonal is just one of the two diagonals in this parallelogram. So when I'm talking about diagonals bisect each other, bisecting means they not only intersect, but they cut each other in half. So if I draw a diagonal AC, as soon as it hits at point M, it now has divided DB into two equal parts. So we can say that DM is the same measurement as MB. Okay? So then not only does AC bisect DB, but DB bisects AC as well. So then we can also say that AM is congruent to MC, sorry. Perfect. So then using that last property, given that FGHJ is a parallelogram, we have to find the measurement of MH and FN. So MH is right here, and then MH is right here. FH is in the entire diagonal. Well, we know that FGHJ is a parallelogram, so the diagonals do bisect each other, which means that FM is the same measurement as MH. So that's got to be 5. So MH is equal to 5. Okay, so then that part's done. So we got to find the measurement of FN. I think it's supposed to be FH, excuse me. I can't even read that. FH. So then the entire diagonal would be 5 plus 5 additional, which would be 10. Alright guys, those are the properties of a parallelogram. Sorry they're a little slow at some parts. I got confused in terms of what I was reading, but for the most part, those are all it. So make sure that you write down any questions that you have, and be sure to ask them in class if you're not sure. Thanks.